Now I am going to solve and discuss this sample problem 3.6. It is from the 3-dimensional equilibrium topic, right. So in this problem it is said that a 200 force is applied to the handle of the hoist in the direction shown. So this is a 200 Newton force applied in this direction which is shown, and it said that the bearing A supports the thrust force. So this bearing is a thrust bearing, so it supports a thrust force, right. So it will support both the radial forces and the thrust forces, right. So if we draw the reactions at this point A at this thrust bearing, right, so it will support two forces, two reaction forces in along the x and y axes. Let me draw it. Let's say that this is the force, and if I draw it here, right, so this thrust bearing can support three forces, right. So one in this direction, right, so this will be, let's say that this is Ax. Let me write this is Ax, and it will also support a force along y direction. Let's say that this is that force, and let's say that this is Ay, and it can also support a force along the z direction. It can support the thrust force, right. So the thrust force will be along the axis of the shaft, right. So this is the Az, right. So if I write, so this is Az, and it is said that while bearing B supports only radial load, right, so load normal to the shaft axis, right. So this bearing only supports the radial loads, right. So if we draw those reactions at this point B, right, so this will be one reaction. This is, let's say that this is Bx, and it can support the reaction along Y. So it can only support these two reactions, right. So this is By. It is said that determine the mass m which can be supported. So we have to find this mass m which the system can support, right, which this system can lift it, right. So and the total radial force exerted on the shaft by each bearing, right. So we have to find these reactions and this mass m, and it is said that assume neither bearing to be capable of supporting a moment about a line normal to the shaft axis, right. So they cannot support any moment normal to the shaft of this axis, right. So again we will solve this problem by using the inspection method. So if I draw axis is at point A, let's say if I draw a x axis is a line parallel to x axis is at point A, let's say that this is that line, this line is parallel to x axis, and this direction is our positive x axis, remember. So this is positive x, and if I draw another line parallel to the y axis, and if I put this line at this point A, right, so this is our y axis is at point A, and this is our z axis at point A, right. So now if I find the summation of moment at A along z equal to 0, so this means that we have to find the moment at A along z, right. So for that we will observe the forces from this direction, right. So when we observe the forces from this direction, so then we will be able to see this x coordinate and this y coordinate, right. So this is that 2D diagram, right. So these are the three orthographic projection of this pulley and this bearing system, this whole system, right. So these are the orthographic projection. This is the top view, right. So the top, we will be able to see the top view when we observe the forces from this direction, right, from the top. Alright, so this is the top view, this is the front view, right, and this one is the side view. So now if we observe the force from this direction, so then we will be able to see these forces, and the forces parallel to the z axis will not be visible in this side view direction, right? So first we have to find the components of this 200 Newton force, right? So first we have to resolve this force. So as we can see that this force will have one component in this direction, and this will be the cos component, so it will be 200 cos of 60. If I write here, so this will be 200 cos of 60 degrees. Similarly, if we resolve this, so then this one will be, we will have one component like this. This will be along the z axis, and this one will be 200 cos of 60 cos of 45, right? So this is 200 cos of 60 cos of 45 degrees, and similarly we will have one component in this direction. So this one will be 200 cos of 60, and it will be sine of 45, right? Sine of 45 degree. So let's say that this is that force F. So the Fx component, this is the Fx component, right? So it is 200 cos of 60 sine of 45. So if we calculate it, so it comes out to be 70.7 newtons. Similarly, the Fz component is again that 70.7, right? So this is 200 cos of 60 cos of 45. If we solve it, so both of these will have same magnitude, and there will be one another component of this force that will be acting like this, right? And this will be the sine component. So the Fy component will be 200 sine of 60, right? So 200 sine of 60 is 173.2, right? So this is 173.2, right? And now if I move this force, this component, so it will be acting here, right? So now we have these three components. So now when we observe these forces from this direction, so we will be able to, this is the side view, right? So this is that diagram, this is the 2D diagram, and we will be able to see this component and this component, right? This component will not be visible since it's parallel to the z axis, and this thrust force will not be visible. We will be able to see this Ax and Bx. So if we add up these, so this will be Ax plus Bx, right? So this is Ax plus Bx, and we will be able to see this Ay, right? So this Ay, and we will be able to see this tension in the cable. That tension in the cable is 9.81 times m, right? So mass is unknown, we have to find that mass. To find the moment at A along Z, right? So those forces will not produce the moment about Z axis which are parallel, right? So this component is parallel. Let me write their names only, right? So this will be, this is Fx, this is Fy, and this one is Fz. So Fx is parallel to Z axis, so it will not produce any moment, right? So these forces which are visible only in this diagram, so they are producing the moment, right, about this point O. They say that in book, they say that we are finding the moment at this point O, and here I am saying that I am going to find the summation of moment at A along Z, right? So about this Z axis, and here in 2D we can say that about this O point, right? So this is the same thing, right? So now as we can see that this Fx is not producing any moment about Z, but this Fz is producing the moment about the Z axis. So we are observing the forces from this direction, so along Z. This Fz is acting along the, sorry, this is Fy, right? So this Fy is acting along, this one is Fx, this one is Fz, and that one is Fy, right? So this component is acting along Y. So the perpendicular distance of this component from the Z axis will be along X, right? So this distance, is 250, right? And this is visible here, right? So this distance is 250. So Fy, Fy magnitude is this is 173. So I will write 173.2 multiply by 250, and these dimensions are in millimeter, right? So this is 250 mm, and this Fy will produce, this is that Fy, right? So this Fy is producing the moment about the z axis is in this direction, right? This direction, or we can say that this direction. So if we curl our right hand fingers in this direction, so the thumb will point out in this direction, that is in the negative z. So I will have to put minus sign here. Similarly, as we can see that this fx component, if we extend the line of action of this fx component, so it will intersect that z axis. So it is not producing the moment about the z axis. As we can see here, this 70.7 Newton force, if we extend the line of action of this force, so this is intersecting that z axis, right? So it is not producing any moment about z axis. So only this component, this Fy component, is producing the moment about z axis, right? So about this z axis, and now these Ax, Ay and Az, they are passing through this point A, so they will never produce moment about this point A, and we are finding the moment at A along Z, right? So we will never consider these three components while finding the moment at point A, right? So now as we can see that these both Bx and By, they are also intersecting with our Z axis, right? So they will never produce the moment about Z as well, right? So now we will consider this tension, this weight, right, this weight vector, and this is 9.81 into m. So if we observe the force from this direction, so this weight is producing the moment about the z axis, and that the direction of that moment will be like this. And if we curl our right hand fingers in this direction, so this in this direction, so the thumb will point out in the positive z direction, so we will write plus, and the weight is 9.81 m, and the perpendicular distance of this weight from that z axis is along x, right? So this weight is acting along y, we are observing along z, so the perpendicular distance will be along x for this weight, right? So the distance along x is this, the radius of this pulley, that is 100. So I will multiply this with 100 equal to 0. So when we solve this, so we here is only one unknown, that is the mass. So we can find the mass directly from this equation 1, right? So if I write, so then this will be, if we add this to both sides of the equation, so we will get 173.2 into 250, right? And if we divide both sides of the equation with 9.81 into 100, right? So we will be left with m. So when we solve this, so m mass comes out to be 44.1 kg. So we were asked to find this mass m, right? So this system can support mass of this much, that is 44.1 Newton, when this much force is applied, that is 200 Newton. So with 200 Newton force, we can lift, we can support this much mass. Now we will apply the second condition, we will apply the summation of moment, this summation of moment at A along x, let's say, and that is equal to 0, since the system is in equilibrium, right? So now if we want to find the moment at A along x, so we will observe these forces from the x direction, from this direction, right? So then from when we observe the forces from x direction, so then we will be able to see this y and z axes, right? So in these diagrams we are able to see this y and this z axis, right? So this is the front view. When we observe the forces from this direction, so then we will be able to see this front view. So this Fy will produce the moment about x axis, right, about this x axis, since it has a perpendicular distance, and this Fz component, if we extend the line of action of this Fz component, so it will pass through that, it will intersect that x axis, is this green one, right? So this will not produce the moment about the x axis at this point A. So now if I write, so then this Fy, the magnitude of Fy is 173.2, so we will write 173.2, and this Fy is along y axis, right? So I will, for simplicity, we are observing the forces from x direction. This Fy is acting along y, so the perpendicular distance will be along z, right? So we have to search the distance along the z axis, right? So this Fy will have this distance 75 plus 100 plus 75, right? So these two distance will be added up, since we are finding the moment at this point A, right? So we will multiply this with 100 plus 75, so this is 175 mm distance, the perpendicular distance of this Fy from point A. And this Fy will produce, let me draw that x axis here, right? So this Fy is producing the moment about x in this direction, right? So in this direction. So if we curl our right hand fingers in this direction, so the thumb will point out in the positive x direction like this. So I will write plus sign here. Similarly, this Fx is parallel to the x axis, so it is also not producing any moment about x, right? This Fz is intersecting the x axis and this Fx is parallel to the x axis, so these two are not producing the moment about x. And now as we can see that this Bx is parallel to x axis, so it will not produce the moment about x. So only this By is producing the moment about x, so I will write By. And again we are observing the forces along from x direction. This By is acting along y, and the perpendicular distance of this By from z axis is this much, this 150. This distance is along x, right? So I will write 150, and this By is producing the moment about x in this same direction, right? In this direction. So if we curl our right hand fingers in this direction, so the thumb will point out in the positive x direction, so I will write plus. And similarly, as we can see, if we observe this weight, this I write, so this weight is 9.81 into m, right? So this weight is acting along y, right? And we are observing the forces along x. Weight has some perpendicular distance, right? So this weight is acting along y, so the perpendicular distance of this weight from this x axis is along z is this much, right? So this 150 plus 100, right? So I will write, and the direction of the moment of this weight about the x axis is like this, right? So let me write here. So this is like this, right? So this is trying to produce the moment about x in this direction. And if we curl our right hand fingers, so the thumb will point out in the negative x direction. So this will be our thumb direction if we curl our right hand fingers in this direction. So I will write minus, this will be 9.81 into 44.1, and this is the perpendicular distance 250, and this will be equal to 0. So now in this equation we have only one unknown, right? So this is By, so we can find that By by using this equation. So when we solve this equation, so By approximately comes out to be 520 newtons, right? So now we know this reaction at B along y. So now if I use this method, if I apply the summation of moment at A along y equals to 0. So now this is our y axis, so we have to observe the forces from the y direction, right? So from this direction. So when we observe these forces from this direction, so then we will be able to see this top view, right? So this orthographic projection, and we will be able to see these forces, all those forces which are perpendicular to y axis, right? And the forces which are parallel to y axis will not be visible in this top view, right? So now again, if we observe these forces, the component of this F force, so then this Fy is parallel to the y axis, so it will not produce the moment about y, right? So this fx and this fz are producing the moment about the y axis, and they are visible in this diagram, right? So they will produce the moment about the y axis. So if I write, so this fx, so the magnitude of fx is 70.7. again we are observing the forces about along y, right? So we will write y, this fx is along x, so the perpendicular distance of this fx will be along z axis, right? So the fx, so the perpendicular distance of this fx from this y axis is how much? This 75 plus this 100, right? So again I have to search for those distances which are parallel to the z axis from the y axis, right? So we will start from y axis, so this is 100, this force, this distance is along the x axis, right? And we are searching along the z axis, right? So this 100 plus this 75, so the perpendicular distance of this component from the y axis is 175, right? And this fx is producing the moment about y in this direction. So if we curl our right hand fingers in this direction, so the thumb will point out in the negative y direction. Let me draw that here as well so that you people can see it, right? So this is the direction of moment produced by this fx about y, right? So if we curl our right hand fingers in this direction, so the thumb will point in the negative y, right? So I will write minus. Similarly, this fz is also producing the moment about y, right? Since it is visible here, right? So this one is fx, this one is fz, right? So this fz, so we are observing the force is along y, this force is along z, so the perpendicular distance will be along x, right? So this fz has this much distance, this 250 mm distance along x, right? So I will write fz, so fz magnitude is again 70.7 and the perpendicular distance is 250, and if we observe the direction of the moment about y, so this fz is producing the moment about y in this direction, right? And if I curl my right hand fingers in this direction, so the thumb will point out in the positive y direction, so I will write plus. So now as we can see that this by is parallel to the y axis, so it will not produce any moment about y. So this only this reaction is producing the moment about y, and this bx, the direction of the moment produced by this bx will be like this, right? And if we curl our right hand fingers in this direction, so the thumb will point out in the negative y direction, so I will write minus. Again we are observing the forces from y direction, this bx is along x, so its perpendicular distance will be along z, right? So this, the perpendicular distance of this bx from y axis is this, along z is this 150, right? So I will write bx, so this is bx and the perpendicular distance from y axis is 150, right? And similarly this weight is parallel to the y axis, so it will not produce any moment about y axis, so this will be equal to 0. So here we have one unknown, so we can find that unknown, right? So minus bx into 150, this will be equal to, so this will become negative and this will become positive. So we can solve this for bx. So bx comes out to be 35.4 newtons. So now we know both reactions at b, right? So by is 520 newtons and bx is 35.4 newton, right? So only until this point the method to solve this problem was difficult. Now it's very easy, right? Once we know the reaction at point B, so now this problem is very easy. Now we can apply the summation of forces along x equals to 0, right? So let me clear this diagram first. So now this bx is acting along positive x, so I will write bx and we know the magnitude of that bx, so that is plus 35.4. Then we will add up this ax since it is acting along x, so I will write plus ax, and then this fx component, and this fx component is in the negative x direction, right? So I will write minus, and fx is 70.7 newtons, and this will be equal to 0. So we can find ax from this. So ax is 70.7 minus 35.4. Similarly, if I apply the summation of forces along y equals to 0, so this by is in the positive y direction, so I will write plus by. Similarly, this weight is in the negative y direction, so I will write minus, and that is 9.81 into mass, which is 44.1, and this ay is in the positive y direction, so I will write plus ay. We know this by magnitude, so I will write the by magnitude, which is 520, is plus, right, and this fy component is acting in the negative y direction, so I will write minus, and the magnitude of fy is this 173.2. So 173.2 equals to 0. So here is also one known, so when we solve this, so we will get the ay component, right? So this will be 173.2 plus 9.81 into 44.1 minus 520. So this will give us the reaction at A along y, and if we apply the summation of forces along z equal to 0, so this weight is acting in the negative the force is along z, right? So this weight is acting in the y direction, so this will not be included, right? So we will add up this az, right? So this az is in the positive direction, so this is az, and minus this fz component, this is in the negative z direction, so I will write minus, and fz is again 70.7, right? So this is 70.7 equals to 0. So az is equal to 70.7 newtons, and let me find this ax and ay. So now when we solve this equation, so ax comes out to be 35.3 newtons, and when we solve this equation, so ay comes out to be 86 newton, and the az is 70.7 newtons, right? So if we are asked to find the resultant reaction at B, so then the resultant reaction at B will be, let's suppose that this is that resultant. So the magnitude of that resultant at B will be equal to bx square plus by square under the root 2. So you people can find it yourself, and similarly the total reaction, the resultant at A will be equal to ax square plus ay square plus az square. So this is the solution of this sample problem.